I'm very pleased to be here, and I thank the Time Institute Nutrition and Care to invite me to present a research topic that passionates me a lot, is whether breast milk could set the child on a path with no allergy. And I will talk to you about the insight from translational research. Okay, so I think there is absolutely no doubt, and you're probably all convinced that breast milk is very important in the short term, meaning while the child is breastfed, he or she will receive lots of advantages in terms of infectious disease prevention. This is true certainly in developing countries, but also in more developed countries. And recent meta-analysis show that about 1 million of life each year could be saved if we could scale up breastfeeding to a universal level. So this is really a fantastic benefit of being breastfed. What is probably less clear, certainly less clear, is whether breast milk can influence your long-term health. Meaning once the breastfeeding has ceased, will the child be put on a pathway with less risk of disease? And today we will talk about the risk of allergy. So if you were in front of me, I would ask you if you believe that breast milk prevent or not allergy. In general, 50 or 70% people say yes, that breastfeeding is protecting from allergy. But then if you go to a systematic review, and here is one that was just published in the Pediatric Allergy and Immunology, this systematic review concludes that there is no evidence that breast milk can protect from food allergy. This is not the only one. You have here from the American Journal Clinical Nutrition showing that breast milk may protect from asthma, but for the rest, there is really no clear evidence. And other meta-analysis and systematic review go to the same frustrating conclusion, is that breast milk is not protecting from allergy. Okay, so I think this is a bit surprising. We may expect breast milk is adapted and would prevent allergy, but it looks like it does not. Why is it so? We may consider that allergic disease are very recent disease and breast milk composition has just not had the time to adapt. Or we may also think on the opposite way, that the environment has changed, the maternal diet has changed, so has her breast milk composition changed. And then breast milk is not adapted anymore to prevent allergy in the offspring. Okay, knowing that and having this in mind, we can just think if there is, however, a potential for breast milk to prevent allergic disease. So how could we imagine that breast milk could protect, and what could be done to make the composition more suitable to protect from allergy in our modern world? So certainly one hypothesis that is worth to envisage, and I'm sure you all think about this one, is that breast milk could be critical to shape the gut microbiota, and we know how important is the gut microbiota for the regulation of the immunity, but also our brain. Gut microbiota is now the center of interest for prevention of non-communicable disease. So why breast milk and how breast milk could play a key role in the prevention of, in the shaping of the gut microbiota? Well, breast milk contain antibodies and particular type, the secretory IgA, natural antibiotics like lactoferrin, lysozyme, and this will influence the seeding and the expansion of bacteria. This is quite a fantastic way of personalized medicine, and I will briefly go through that because this is really the personalized medicine, the best existing, I think. You have here a lactating mother, and she has certain gut microbiota, and she may also be infected by a pathogen. The B cells in her gut will be activated, and some of them will expand in response to those pathogen or to the common cell, and then they will migrate to the mammary gland. They will then differentiate them in antibody secreting cells and will produce IgA in the breast milk. Thus, the baby will receive maternal IgA that will protect the infant against the enteric pathogen from the closed environment. So it's really specific, one breast milk in one environment at one period of the time of the year will contain certain antibodies, and another time and another place other antibodies. And similarly, the antibodies in the maternal milk will really be dependent of maternal gut microbiota. So you see that this IgA in the breast milk is really something personal depending on each mother. And recently, a group demonstrate and show that you have different IgA in breast milk of children that will or not develop allergic disease. So this is an association, but it suggests that indeed different pattern of IgA in breast milk may condition the gut microbiota and then the allergy risk. So that's one way, certainly very important in view the huge amount of IgA in breast milk. Another way that is certainly very important and has gained attention in the last 5–10 years is the presence of bacteria in the milk. We call them probiotic. We expect these are beneficial bacteria, and this bacteria that we thought initially it's just a little bit of bacteria is not that low amount. A child will probably eat about 10 to the 5, 10 to the 7 bacteria a day, and an elegant study by Panaraj showed that about 1/3 of the bacteria in the gut of an infant are originating from the breast milk, and 10 additional percent are coming from the areolar skin. So the microbiota of the milk is also very important and will influence the seeding of the gut microbiota of the infant. And in this regard, also here from another group showed again how the allergy development is associated with the consumption of breast milk with a reduced microbial richness in the first months of life, showing again how breast milk and microbiota can directly influence the risk of allergy. And the third way that we can schematize here that is certainly important is the famous human milk oligosaccharides that you have all heard about, like the 2FL that are now added to certain formula. So these human milk oligosaccharides are food for bacteria. So this will allow to expand certain bacteria, and in particular, the one that we expect to be beneficial, like the bifidobacteria, and they will influence the metabolism of those bacteria. And you know that it's really the metabolites produced by the bacteria that are important for immune regulation. And again, here, I'm going to show you a slide here, a study done by the group of Megan Azad. And she and her group found in the child cohort in Canada that there was a certain pattern of human milk oligosaccharide that was associated with the development of allergic sensitization during infancy. So it's not one or another, but a certain pattern is associated with more or less risk. So knowing the importance of the gut microbiota, and now just having a review with you the 3 different ways breast milk can shape the gut microbiota, we can think about how to modulate this factor, how to modulate the human milk oligosaccharide, how to modulate the probiotics in the breast milk, how to modulate the IgA in the breast milk, and knowing that we may influence the seeding of a beneficial bacteria, a microbiota in the offspring, and thereby decrease allergy. That's one possibility we may work on. Another one, and another way probably breast milk certainly play an important role in the food allergy prevention and in general immune regulation is the influence of breast milk on the barrier. You all know how important it is to have a good barrier to be protected from allergy. Allergic disease are disease of barrier. So we know that in the beginning of the life, the gut epithelium is still leaky. This is physiological. and progressively the epithelial cells will become more tight and make an anti-inflammatory and strong barrier. So it's important to know what is driving this maturation of the gut barrier. And we can go to a study published 50 years ago, and that demonstrates the key impact of breast milk on epithelial cell proliferation. You can see here proliferation of epithelial cells in the presence of mature milk, and here in the presence of colostrum, and you can see how important is the effect on the proliferation. And it took some decades then to identify that this strong proliferative capacity was related to the multiple growth factor you have in breast milk, and in particular epithelial growth factor. So again, playing on the level of this growth factor in breast milk may be a way to reinforce the barrier and hopefully prevent allergy. And now I will go in the second part of this talk on the research my team is mainly interested in, is whether breast milk can promote oral tolerance. And again, if you were here in front of me, I would ask you what you know about tolerance, and then we could discuss, but I will go on my own and hope you find this clear. So you have certainly heard about the concept of immune tolerance in the context of food allergy prevention with the new guidelines. What the new guidelines propose, and certainly following the very nice work from Gideon Lack in the field of prevention of peanut allergy, also of Debbie Palmer here in Perth for the prevention of egg allergy, is that to avoid the child to be sensitized, for instance, through the skin, because you have in the dust some eggs, some peanut, and that could go through the skin of the baby and sensitize him early on. The idea is to introduce as soon as possible possible allergens, such as peanuts, such as egg, to go through the gut and thereby induce tolerance. Because we know the gut is prone to immune tolerance. It's a good way to induce an education of the immune system towards the acceptance of the antigen and no inflammation. So these strategy of early introduction are extremely promising, certainly for peanut, less clear for egg. What is less clear for the egg, and what may be a problem, is that up to 1 in 3 children are already sensitized to egg at 4 months. And introducing egg, and in particular raw egg at 4 months, can lead to allergic reaction, including anaphylaxis. So this is quite a serious issue. So the question is, maybe it's 4 months is already too late. The baby is already sensitized. So could we act early on? And of course, you understand we will go to the breast milk. Could we use breast milk to already induce immune tolerance so that when the baby will eat for the first time egg or peanut, he will be protected and will not develop food allergy later on? So this is the hypothesis we've been looking at. Why? Because you all know, and certainly the breastfeeding mother know, that what they eat is going for most of the part in the breast milk. You go to a Thai restaurant, your breast milk smells garlic. We know how breast milk is composition is influenced by our diet. And indeed, you can find in the breast milk egg antigen, peanut antigen, cow milk antigen, gliadin. All the antigen that you eat have been found in breast milk. So breast milk is like a cocktail of what the mother is eating, but it's just very, very low amount. It's in the range of maximum 1 nanogram per ml, meaning that the baby will eat less than 1 microgram per day of those allergens. And interestingly, also these allergens are pre-digested by the mother. There are lots of protease in the mammary gland that will pre-digest all these antigens. They can be found in the intact form, but also in small peptides. Now, if you compare the exposure of a child to breast milk containing allergen to a child that is not breastfed and is exposed and is eating formula milk, he will receive mainly one allergen, and this will be way more higher level in the range of milligram per ml. And in case it's not hydrolyzed formula, the antigen will not be digested. So you see how different is the allergen exposure from a breastfed infant compared to a non-breastfed infant. But does it matter? Could this have any consequence for the immune system education of the infant? We believe that yes, because in addition of being in very low amount, you have also multiple immune modulators, meaning molecules that can influence the immune system. So now 12 years ago already, I started a postdoc and I decided to address that hypothesis. And I tested in the mice the idea that a baby exposed to an antigen through breast milk would develop immune tolerance and thereby would not have food allergy if exposed to the egg through the gut, and would not react to the egg antigen in the periphery neither. And we test that in a model of asthma, and we find that indeed, if a baby receive, and I talk about mice, if mice receive during the breastfeeding period antigen through the breast milk, they will be protected from egg allergy, both locally and systemically. So that was, let's say, what we call a groundbreaking study, because 12 years ago, we were still in between thinking avoidance, exposure. So this was really a proof of concept in the mice that you can induce tolerance to very low amount of antigen in breast milk and in the long term prevent allergy. That was in the mice, and it took a while to translate that in the human. And here is the translation to the human that was just published in Allergy. So we had access to a birth cohort developed by Susan Prescott. Here is that birth cohort where she had an arm where she gave a fish oil to infant and another arm with no intervention. And this is the arm we used for this study, the control arm. And so we had 88 breast milk sample together with the egg allergic outcome at 1 and 2.5 years. In this cohort, we did analyze the level of egg antigen, and as you can see here, the level of egg antigen are very low in the range of 100 picogram per ml, and you can see here the level at 3 months, at 6 months, quite similar. About 50% of the sample we had tested contain egg in this very low amount. We also analyzed whether you could we also analyzed the representation of this egg antigen at 3 and 6 months, and try to see if a mother that has egg antigen has always egg antigen in her breast milk versus one time yes, one time no. So you can see here that we distinguish 1/3 of the breast milk sample of mothers had never any egg antigen detectable in their breast milk, neither at 3 nor at 6 months. And then we had a series of samples where we had breast ova detected at both time points or only at 1 or the 2 time points. So from there, we were wondering if there was a difference in the outcome of the children that were exposed to breast milk with no egg antigen or were exposed to breast milk containing egg antigen at some time point. And therefore, we addressed IgE-mediated egg allergy at 1 and 2.5 years based on the skin prick test and doctor clinical diagnosis. So here are the results. You can see here in this birth cohort in Perth, this is a high-risk cohort, and you can see that the prevalence of egg allergy at 1 year is very high. about 14% of infants have IgA, IgE-mediated egg allergy, and at 2.5 years, about 9%. Now we try to see whether the presence of egg antigen in the milk had any influence on this risk. And you can see here the data at 1 year and 2.5 years. In white, these are the children that were exposed to breast milk that did not contain any egg antigen. And you can see that we have about 20% of children having egg allergy at 1.5 years when there was no egg in the breast milk. If the infant were exposed to egg antigen in their breast milk, at 1 year, you have a reduction, but that is not statistically significant. And at 2.5 years, you see that many more children have outgrown their allergy, and we have only 5%. So you can see here a fourfold decrease in egg allergy risk at 2.5 years in children that were exposed to breast milk containing ova at one or the other time point. Of course, these numbers are low, and of course, there may be a confounding factor because this is not a randomized controlled trial, but this supports and go in the same direction as the data we find in the birth cohort, in the mouse model. Having an egg antigen in very low amount in the breast milk is associated with a reduced risk for egg allergy. So yes, there is hope. How can we should now, of course, verify all this in a randomized control trial, check the presence of egg antigen in as many samples as possible, and then if we prove all that, we may, of course, want to increase the chance of having ova in breast milk. So you may say, okay, that's easy, just let's eat eggs. Well, that may not be that easy, and in another randomized control trial, the group of Debbie Palmer compared intervention where a mother were not eating any egg versus up to 5 eggs a week, and she measured the level of egg antigen in the breast milk. And surprisingly, and this has been shown in other studies, 1 in 4, 25% of mothers eating 5 eggs a week had no egg antigen detected in their breast milk. So we need to understand what is controlling the transfer of an antigen in the breast milk, as this may be very important for the induction of protection. So to summarize what we found in the mice and also in some birth cohort study, you can here extrapolate the trajectory with the risk of a food allergy for a child that is exposed to breast milk that does not contain any egg antigen. In the mice, we could also determine that having only the egg antigen in the milk, just if milk was like water, that would not change anything, that will not induce any protection. If you have some protection through breast milk, that's because in parallel you have cofactor, what I call the immune modulators in the breast milk, such as the TGF-beta. And in the mice, we could show that this was very important to confer that protection afforded by having egg antigen in the milk. We also address other factors such as vitamin A, and this was very important to ensure oral tolerance induction from the very first day. If you have high level of vitamin A in the breast milk, this will help to strengthen the gut barrier and increase the immune development of the gut, and then you can induce oral tolerance to antigen in breast milk from very early on. Another factor we found super important was the presence of immunoglobulin, not the IgA I was talking in the beginning of that talk, but IgG, and we found that this form immune complex and that allow a very good transfer and presentation of the antigen. So you see here, those data that are mainly obtained in mice show the whole heterogeneity that we see also in human birth cohort on protection of allergy by breast milk. If you don't have an antigen in breast milk of all the antigen but no high level of immune modulator, you will not protect the child. While having some immune modulators like TGF-beta, vitamin A or IgG give a much different risk and is protecting. So you see the range and how we can try to now understand how to modulate that, how to have an antigen in the breast milk, how to have TGF, IgG, vitamin A levels that are sufficient to induce protection. So these are the good guys. But then recently we had research showing other factors that we should try to counteract. And I will talk you now about house dust mite. So you may find surprising I'm talking to you about house dust mite while I'm talking about food allergy. So why am I talking to you about house dust mite? Well, here are the surprising results. If you look in the breast milk, you can find antigen from house dust mite, and in particular, we have been looking at the P1, the one that are interested in asthma, allergic rhinitis, or probably know that this is the major allergen for asthma and allergic rhinitis. Well, we found that respiratory allergen is also found in human breast milk, and similar level as egg antigen. So you can see here that the level of the P1 are in the range of also 100 picogram per ml, just like the egg. How does the P1 get into the breast milk? Well, in another study, we found that the house dust mite are in fact ingested, and then you get the allergen in the gut of the mother, and this will go into the breast milk. So I will not go through the detail, but just show you the result of a study we did in the mice that was just published in the Journal of Allergy and Clinical Immunology. And we could dissect the mechanisms, see what's happening. So in fact, in contrast to egg, having house dust mite allergen in breast milk is not a good event. We found that the protease of house dust mite will cleave the gut barrier, will induce inflammation in the gut of the neonate, will activate immune cells that will lead to the development of T helper 2 immune cells that orchestrate the allergic response. The good thing is that we identify the protease of the house dust mite as key to induce all this cascade, meaning that now we have a target. We should find, and we are trying to find how to neutralize those proteases to abolish this cascade. Because why do we think it's important to abolish this cascade? Because we found also that having those T helper 2 cells in the gut was not good for oral germs. Now, if you have a mice that is inhaling house dust mite, having this in the breast milk, and then at the same time this mice is eating egg, well, in contrast to what we found before, we cannot induce tolerance anymore to egg, and we cannot prevent food allergy. So to summarize, if you want to induce oral tolerance to egg, prevent food allergy to egg, you have to have the egg antigen, yes, but it should be in the absence of house dust mite protease, because this one will totally abolish the possibility of protection. So that's in the mice. Of course, we wonder if this is the same in the human, and again, there is a limitation, is the number of cases. So you see here 100 breast milk sample where we have analyzed the egg antigen level and the house dust mite antigen level, and we find 25% of breast milk in each category. Some breast milks that contain neither egg nor house dust mite, some contain only house dust mite, some only egg, and some both. And I guess you would like to know if the children that have been exposed to this different kind of breast milk have different risk of egg allergy. So for the one that would like to know this, and I hope it's all of you, you can see here a very distant risk of egg allergy according to this different composition of milk. And as expected from the mice study, and what I showed before, having egg antigen in the breast milk but no house dust mite is the best case. You have only 4.5% of children having egg allergy at 1 year. The one that had house dust mite have the worst risk. 21% of the children had egg allergy if they had house dust mite in their breast milk but no egg. and having the combination of both abolish the protection that we see with egg antigen. So I will show you the data in comparison to the mouse data. So this is the human data, these are the mouse data. And even though those numbers are low, you see how surprisingly they are similar to what we found in the mice, meaning that mice here that were exposed to breast milk without antigen have a certain risk of food allergy later on. The risk is the lowest with only the egg antigen. And when you have the egg and house dust mite, you abolish this possibility to be protected from egg allergy. So we will go to the conclusion and the perspective. What we do currently in the lab with the mouse model and also with human sample is to find out how to modulate the breast milk composition to neutralize this house dust mite polygenic activity, as we think this is a real important way to act to promote immune tolerance through breast milk. This is the summary of all the factors we have been assessing during these 10 years, and that gives us a wide range of targets to try to tackle with maternal intervention. So, coming back to the question whether is there some hope that breast milk could protect food allergy and allergy in general, we can say yes. Breast milk has the potential to influence the long-term allergic risk because of its impact on the shaping of the gut microbiota. However, currently we still do not know how to do that and what's the ideal microbiota to prevent food allergy and asthma. Breast milk has the potential to protect from allergy because it's promoting strong gut barrier, and we know how having a good gut barrier and not a leaky gut is important for immune regulation. And the last part of the talk, I showed you how the antigen in breast milk can influence the long-term risk for allergy, how egg antigen is certainly protective from mouse data and human data, and how house dust mite in contrast may be a problem, but we know how to act now and maybe work on the protease. So the next step is to find out how to intervene by the mother, maybe to the neonate, to change that path and make the child not allergic, because he will receive from the very first days of life, the first month through breast milk, the correct information to educate towards no allergy. So this is it. I hope you assimilated all this information. And if you have any questions, suggestions, comments, would like to know more, you can chat, use the chat platform of the webinar, or you contact Bink through the email that is addressed here. And before finishing, I would like to thank you, of course, and highlight here the great team with whom I'm working here in Perth. Lieke van der Lens, Akila Rekima, and Patricia Machiavelli. Thank you very much.